Thank you, Jessica. Appreciate that. Good afternoon, everybody. Hope you're doing well. Thank you for joining us on this webcast. And I've had the opportunity to spend a lot of time with the Zimmerman tools over the past couple of years, and I'm very excited to be able to discuss that with you today. Today, we're going to be talking about, in particular, a new poster that SANS has just published, and it's on the command line version of the Zimmerman tools. We wanted to emphasize the command line version first because A, it's scalable, and B, it is something that maybe some folks have a little bit of apprehension about. So to give them kind of a kickstart in being able to use these command line tools. So with that, just a couple of announcements before we get into it. There is a link shown on the screen that you can actually register and have SANS send you a paper copy of the poster if you wish. So that is open until March 19th. So if you'd like to have a paper copy of the poster, click on the link, fill out the form, and they will send you one. Other announcement is that Eric will be teaching his new 498 Battlefield Forensics class in Orlando, April 5th through the 10th, and he will actually be there signing these posters, so another way to get your hands on a paper copy. All right, this afternoon we're going to talk through a few things. Some of them are going to be just trying to get you prepared for working in the command line environment, some tools that will make your life easier in that environment. And then we'll actually get into the tools themselves. So we're going to talk about why we actually have a poster on tools, how to get and install the Zimmerman tools, how the poster is organized so that you can make the best use out of it, some common conventions that are used in the command line tools, some other supporting tools and methods, and then we'll jump right into a selection of the Zimmerman tools. We're not going to have time on this webcast to go through every single tool. So I've selected a few that I think will give a representative sample of how we have simple tools that are very powerful but yet easy to use, and some tools that are a little more complicated, but with that complication comes even more power. So SANS has put out quite a few posters over the years, and those posters tend to be focused more on artifacts, methodology, that type of topic, versus a specific tool. In general, SANS is tool agnostic, and they try to demonstrate in their classes an open source tool and a commercial tool that meets a particular artifact's needs. So this is the first time that we have a poster that is exclusively focused on the tools themselves. So when we talk about tools, the tools that we teach in class, we're often looking for tools that help us gain a better understanding into a specific artifact, as well as makes us more efficient in our processing. And today, when we talk about more efficient, not just in our ability to process a single image, if you will, but our ability to scale that process. And that's where the Zimmerman tools really shine. So I guess the bottom line is that we have a set of tools that have been made freely available to us by someone who's dedicated to sharing with the community. And therefore, we thought it would be most beneficial to just dedicate a poster, not just this one poster. This is the first in a series of 3 on the Zimmerman tools to help the community better use those tools. So we're going to look at command line tools now. In the near future, we'll have a poster on CAPE. And then following that, we will have a poster on the GUI version of the Zimmerman tools. So first thing is, how do I get my hands on these tools? You may or may not be using them currently. If you have not used the tools, you owe it to yourself to spend some time with them. At least that's my opinion. And here's how you would get it. If you go to the URL shown here on this particular slide, download that single file. It's basically a PowerShell script. Unzip the script and run it. So very easy. We just jump over. I have already created a folder called Easy Tools. And in that folder, I have the script, so we'll need to unzip that real quick. And I'll just show you how easy it is to get this started. So I've downloaded the script already. I already have it in a folder that I have set up to hold the Zimmerman tools. This can be any folder of your choosing. The one that I'm showing you here is just for this demonstration. My production copy, if you will be run from a different folder. So I have the unzipped script here, and I just run it. And we're not going to watch the whole thing run, although it does run very quickly. It'll probably take 20-30 seconds to run. But I just wanted to show you how easy it is to download it, unzip it, and run it. And here in a few seconds, you'll have a fresh copy of the Zimmerman tools. This same script that I just ran, the get Zimmerman tools.ps1, is also the update script. So anytime that you need to check to see if there's an available update, or just run the script to get that update, you run the same script again. In fact, we're almost done here. I'm just going to let it finish, and I'll show you what that would look like, meaning what the update run would look like. There we go. So it ran that quickly. Now, if at some point in the future I want to update the tools, I run the same script again, and it will tell me if there's any updates. If not, it'll tell me that I'm current and I'm good to go. Okay, so that easy to get a copy of the Zimmerman tools. So there's a set of conventions, command line options and switches that all of the tools share. So I wanted to spend just a moment to explain those because we'll use them over and over again as we go through the various versions of the command. So a couple of required parameters. We either have to have a -d or a -f, so TAC-D, TAC-F. And what that means is we're going to process a directory or we're going to process a file. So it's required. We have to tell the tool what we're processing as far as is this option to follow a directory or a file. The TAC-Q means quiet mode. I'll show you as we get into running the commands how big a difference that can make. But the overhead in writing to the screen when we run command line programs is pretty significant. So we have the ability to turn that off if we wish, and that will directly translate into that command running faster. We can change the date format that we get when we output to CSVs with the tac-tac-dt. Tac-tac-mp just gives us the ability to have higher precision on our timestamps. Output file formats are CSV, JSON, or HTML. So when we do a tac-tac CSV, what we are supplying next is the folder, is the directory to which we want our output written. If we wish to give it a specific name, we would use the next option, the tac-tac CSVF, F for file name, and we can supply a file name. If we don't do that, the tool will generate a file name on its own. In a moment, we'll talk about what that file name, how it's constructed. Debug and trace give us the ability to have additional output information when we're trying to find out why a tool is not producing the results that we were expecting. The sync option, in this case, only applies to one specific tool. It's the Event Log Explorer tool. Event logs have a concept called maps, which we will discuss in a moment. And the ability to update those maps is controlled with the sync option. So when we provide the sync option, we're basically telling Event Log Explorer to go out to GitHub and grab the latest version of the maps. And then last, the tac-tac VSS allows or tells that command to process, in addition to the live data, process volume shadow copies. Volume shadow copies can be extremely valuable. Basically, it's a backup of data that has been previously on the system. Not all commands support the VSS option, but we'll show you which ones do. So each section, each tool will occupy a section on the poster. Within that section, we have various pieces of information that we've tried to stay consistent with. So as you move from tool to tool, you'll know where to look for specific pieces of information. Okay, the artifact. A lot of the tools have a one-to-one relationship with a specific artifact. They're designed to process that one artifact. So we'll have information about the artifact itself. Then basic usage of the tool. How do I run it against a single file? How do I run it against a directory? What are the common options that I may wish to use for this specific command? And then key data return. So what should I expect this tool to return to me, either on the screen or in some output format that we have selected on the command line? The formats again are CSV, JSON, HTML, and I think that some of the commands also have XML. And then finally, we have advanced usage or pro tips. So tricks and tips that we've learned along the way and working with the tools that we wanted to share with you. So most commands will have that section, and a few commands will have a section that provides you a link to additional information. And when we get to those, when we get to tools that have that section, I'll talk briefly about what it is and why you may wish to go to that URL and download additional information or even download some scripts. So the output naming conventions. As I've said previously, but I want to just make sure that we're clear on this point. When we give the tac CSV, what you're providing next is the folder, the output directory, not a file name. If you wish to give a file name, then that is the CSV option, CSVF option. And if not, then the tool will create a file name for you based upon these components. So basically, it'll start out with a timestamp. It'll have the name of the tool in the file name, as well as some type of output designator at the end. So what you're looking at here are basically two file names that were generated totally by the tool. So meaning there was no CSVF option provided. At the end of the presentation, when we talk about the command line version of Registry Explorer, I'll spend a little more time talking about the naming conventions used there because it is slightly different. So tools that have specific support for volume shadow copies. The Ventlog Explorer, the MFT Explorer, Prefetch, and Registry Explorer. All you have to do to invoke the ability for the tool to process volume shadow copies is to just supply the tac-tac-BSC option, and that's all there is to it. There's another tool that has a command line version. This tool is called CAPE. I will mention that from time to time as we go through the presentation. And as I said earlier, there will be another poster that will talk entirely or exclusively about CAPE. But in this context, using CAPE, it has a VSS option, and therefore, if you're using CAPE as a wrapper around Zimmerman tools or other tools, you can therefore invoke the volume shadow copy capability. Sorry, one sec. I'm reading a question here. So, Stefan. So I'm going to try to answer some of these questions as we go. If they get too voluminous, I'll put them off to the end. So the one comment about will this webinar be uploaded to YouTube? It will be made available offline. That may be through a link to a SANS link, and eventually it probably will go to YouTube, but I will let Jessica further answer that. And let's see, Stefan had a question about okay, so Stefan's point was he just wanted to make sure that we point out when we get to the event log section, that we emphasize the fact that the time zones mentioned there will be UTC. Yeah, so just the comment I would make is that we should, as a general practice, try to have your analysis machine's time zone set to UTC, so that if there is an issue with conversion from a local time zone to UTC, that will minimize the impact of a tool doing that conversion incorrectly. But yes, there are instances where we just have to know what specific data is in what time format and make the appropriate adjustment. But thank you for pointing that out. And I think, well, I'm going to continue on with the webinar and try to catch some of these questions as we go. I think there was another question on time zone, and yes, in general, time zone output from the Zimmerman tools is going to be in UTC. All right, so I'm going to now jump onto another concept that we need to have an understanding of as we move through the rest of the command line tools, and that is the concept of dirty registry hives. This has been in place for quite some time, but the understanding of it maybe is relatively new. So registry-related transactions are written to a transaction log first. They are not written directly to the registry. So from time to time, those logs have to be flushed and written to the registry file itself. What that means is that at any point in time, there can be transactions that have happened and have been written to the logs, but have not been flushed to the registry hives themselves. When that condition occurs, we call the registry hive, the target registry hive, dirty if all the transactions have not been written to it. So when you see, as in the screenshot, what we're looking at here is Windows System 32 config, and in that folder is where the system registry files are stored. You'll see that there's a pair of log files for each of these system registry hives. So SAM, security, software, etc. have security.log1, security.log2 as an example. Okay, so if the transactions in those files have not been written to the registry hive itself, the Zimmerman tools will recognize that and ask you how you want to deal with it. And your answer is supplied in the form of a command line option. So the tool can automatically determine whether a registry hive is dirty or not. It has the ability to automatically update those registry hives. The default, at least for the command line version, is to create a copy of the hive in memory, update the copy in memory, and use that copy in memory when the tool is being run. Summarize that, meaning that the registry file that's on your hard drive that you have pointed the tool at is not being updated. That works a little bit differently in the command line, in the GUI tools, where it actually asks you, would you like to save a copy of it? You can tell the tool to specifically ignore this condition. So if you don't want to have the registry transaction entries flushed and put in the registry file, you can tell it to skip that. And that could be a performance issue. The other thing that goes along with this is the fact, that we have a tool, RLA, which will allow us to create clean copies of registry files. So provided a registry file and the log files that go with it, the tool RLA can take those two, put them together, and create a new, quote unquote, clean copy of that registry file. Now, although it happens automatically, you may wish to consider doing this step as a performance consideration. You know, why reprocess this file time after time if I can do it once up front? I'll talk more about that in a moment. All right, so I put together a little table way back when SANS first published what we refer to as the red poster, the Windows Forensic Analysis poster. There was a color coding associated with different types of evidence. So we refer to this as to evidence of ... So evidence of file download, evidence of file opening, creation, etc. So I created the table that says by tool, here are the different evidence of categories that tool may help answer. Okay, so just a little extra, you can use it as you find beneficial. Some of the tools you'll find that I have expanded the designation beyond what the poster says. A good example of that might be JLE-CMD, so that's the jump list tool. And obviously jump list tells us things like file opening and creation, possibly program execution, but I've expanded that to other areas because with the interpolation of the data that's there, I think that we can take it a step further and say that I can get at these other areas of information also. As an example, a jump list may tell me that this specific program ran and it ran against a file and that file lived on a removable drive. That way I can infer USB usage. So we have to talk about, or at least I think it's going to be beneficial to talk about, one of the GUI tools. So Timeline Explorer. Timeline Explorer was initially developed to make it easy to review timeline CSVs, mainly log the timeline, Palazzo timelines, and do some color coding on those timelines, just like we were doing in Excel. And the reason for the standalone tool is we didn't always have Excel on every single forensic workstation that we were using. We didn't necessarily have it in the field. It wasn't something that we could install on a thumb drive and take with us. So we had the standalone tool for timelines. That has now evolved into a very full-featured CSV viewer. So I can use it to load and view pretty much any CSV. It has amazing capabilities as far as searching, filtering, sorting, grouping by specific columns. It even has conditional formatting, and it's extremely lightweight, meaning that executable is very small. I would have it on any USB or any type of tool drive that I would take into the field. You should have a copy of this. It's kind of like the old, American Express commercials with Carl Malden, never leave home without it. So one more last topic on, supporting tools or methodologies that are going to make your life easier with the command line tools. That is, how do we mount the evidence that we get access to? So we have various sources for our data. One common source is going to be a forensic image file, an EO1 format as an example. Well, the Zimmerman tools can't read the EO1 file format directly. And that was intentional. There was no reason to do that because there were a lot of different tools that can make that particular file format viewable as a drive. They do that to varying degrees of success. Okay, so when we recommend a tool to mount EO1s to mount that forensic image, we recommend Arsenal's image mounter, AIM. AIM has a free version and it also has a commercial version. Just use that tool when you're mounting EO1s. I guess I'll just leave it at that. There are other tools out there that we have probably all used in the past. And the biggest distinguishing factor between other tools and Arsenal is that when you mount an EO1 with Arsenal AIM, it looks to Windows as it is a physically attached drive to the system. So that's exactly what we want. So use AIM when you're mounting your images. The other thing to talk about is that if you're using something like CAPE to do your initial collection, you may choose to store the data that you have collected in a VHD or a VHD-exe format. Our ability to start thinking about it that way, to use that as a container, has made life very easy. So with the CAPE collection, I have a VHD-exe typically. To mount that, all I have to do is double click it. No special tools required. It's just as simple as double click it, and I now have access to that data. So we have to have our data. We have to have our data accessible to us. If it's in one of those two file formats, it's in some type of container, we have to make that container available as a drive or at least as a folder structure. Other thing to point out is the fact that sources, the directory or the file that we're going to process with one of the command line tools doesn't have to be local. I can point it to a UNC path to do a collection or process data somewhere else on the network. So keep that in mind. It doesn't have to be local, and I'll show an example of that. All right, so we've kind of done all of the upfront kind of the supporting information that we're going to need to use the tools. And now we're going to bounce into looking at some specific tools. Once again, this isn't going to be the complete list of tools that are covered on the poster. Just not enough time for that, but certainly a very good representative sampling of the tools. So first we're going to jump into the LNK File Explorer. Now, LNK file, so what I'm showing you here is that back to how to use the poster. Basically, we're going to talk about the artifact that is specifically being processed by this tool. Well, as the name implies, we're talking about LNK files. LNK files are also known as shortcuts. And the LNK files that we're really, most probably interested in are the ones that are created automatically behind the scenes by Windows when a file is opened with a GUI application. Okay, so some folks, the people that we may be investigating, may not even understand that this file is being created. And I guess the old adage is, if you want to get away with data exfiltration, taking files that you shouldn't be taking from somewhere, don't open the file. Opening the file is one of the noisiest activities that you can do on a system. And that starts right here with LNK files. So the LNK files are also one of the forms of shell items that we talk about in Windows forensics. The other two being jump lists and shell bags. So basically a shell item is a pointer. It's a pointer to some other object. And in the case of a LNK file, that other object is another file. So the basic usage, we have to do one of two things, and I'll keep reminding everyone of this. So I have to point it to a file, or I have to point it to a directory. Okay, so those are going to be the two options that are required, and then there are some optional ones that we may wish to use. So the key data that is returned by the LNK File Explorer, a set of timestamps for both the target file as well as the source file being the LNK file itself. Lots of good information about the drive that the target file was located on, whether it was a hard drive, removable drive, volume serial number, volume name, etc. We can also derive information about the specific file system. If it has an MFT number and a sequence number, we can infer that that came from an NTFS file system. So in this particular tool, just looking at data that is returned from it, we can infer some things about the target file itself. So if all the timestamps are the same, meaning the source created, modified, etc., are the same, we know that this file was only opened once. Okay, because this particular timestamp gets updated every time a file is opened. If they're all the same, it's only been opened once. If they're different, then we can infer that it's been opened more than once, or at least twice. But we really don't know the exact number, because it could have been, we have the first time, we have the last time open, and that's all that we can infer from that. Also, when we see a situation where we have a creation date after the last modified date, we can infer that that file was copied, because the creation date was the date that it was created on that volume, and the modified date was inherited from the original file. And for each command, there may be pro tips. The tips that we're talking about here is basically just a reminder that two things. A link file may have an extension in it, prior to the .lnk extension, or it may not. Windows, the versions of Windows keep going back and forth on this. So it just depends on what system you happen to have gotten your data from as to whether you're going to see that extension in the file name or not. Having the extension is nice because it helps us understand or potentially understand what program was used to open that file. And then the last point there is that link files point to the last file of that name. So if I happen to have 3 files named exactly the same thing in 3 different folders, and they were all opened at some point, the only one that I'm going to know about, or at least know about through a link file, is the last one. Okay, so we'll get into a demo here in just a second. I'm going to just briefly show you some commands, and then I actually want to run the commands for you. And the reason I want to run the commands is that, not for you to watch me type, but so that you can get familiar with that command line environment, and you can see the speed at which these commands run. So the first one, basically I am running link file explorer against a single file called businessplan.lnk. The next one, I'm running it against a directory. And because of that path, it's likely that I'm running that against a live system, C:. And then the last part of that is that I am going to store my output in a folder named out/LECmd. I did not provide an additional file name, so the tool will name the file for me. Lastly, and I'll try to do this on each command, is to show you that cape can be used to not only collect the data, but also process it using the tool. So here, I've told cape to go collect link file and jump list information, told it where I wanted to store that information, and then in the same command line, I have said, also use LECmd, Link File Explorer, to process the data you just collected. Okay. Now, in most cases, you may have already collected a great deal of data and have it available to you, but the one-of type collections is where cape really shines. So as an example, if I needed to reach out across the network and do this really quick collection and then processing of files, I could change my T-source to be some UNC path and go collect it from a machine on the network versus collecting it, say, locally on this machine. In Timeline Explorer, this is just a quick view of what the output of LECmd is going to look like. All right, so let's look at some of this online or demo it for you. So first command I'm going to run is I'm just running this against a single file. This particular file is on E:, and I'll just tell you, from my convention, I've used AIM to mount an E:01, and I am looking at that mounted E:01 to process this file. And that's how fast it runs. I mean, that was, certainly less than a second to run. Quick look at the information that's returned in this command. So we have source file information. So this source in this case is the link file itself, meaning it's that file. The target is the actual file that was opened and its data and timestamps. As I scroll down the page, some additional information. I see that this was looking at the volume information. See that it was on a removable drive, on a USB thumb drive. I see that I can get the volume serial number, I get the volume label, as well as I can see the path within that particular device. So this is just for a single link file that was being processed. There's other information here, but in the interest of time, I would just kind of hitting the highlights. This command, I am running something very similar, except that I'm just going to go out against a specific directory. I'm going to process a directory full of link files. This is a file structure that I created myself, and I had extracted link files from an image. The --csv tells me the folder that I'm going to save that data in, and I'm going to give it a specific name. I'm going to take off the --tac real quick to show you what happens if you don't run this in quiet mode. Lots of noise coming across the screen. Now, true, it only took 6 seconds to run, but if I include the --tac, now it's less than a second to run. So just emphasizing the fact that we can use that option to greatly increase the speed at which the command runs, because it doesn't have the overhead of writing that extra data to the screen. And then quickly look at the output of that. So we're now using Timeline Explorer to look at the output from LECmd. So all the things that we saw more in inline format, we now see in tabular format. Very easy to view in this format. One of the things that we can do is I can filter on specific items. Let me just clear what I've got here. So I can just type in start as an example, and any source file name that had start in it would be left on the screen, everything else would be filtered out. So I can filter that way. Of course, I can sort by just clicking on the column. Can get rid of the filter by just clicking the little filter icon here and clearing the filter. One of the other things that we can do is group by. So I have a volume serial number here. If I took the volume serial number column and drug it to this row for group by, I can now see that of all those link files, I've got these specific volume serial numbers that have been referenced. And then I can drill down into those by just expanding each one. So sometimes it makes sense to use this feature just to kind of get an idea of the data that you're looking at. And then you may put it back away and do your analysis in this normal view. So we have all our dates and times. We can certainly filter on those. So anything that is here, we can filter by it. We also have the ability to sort. And we have a search box up here, which works one of two ways depending upon our settings. If I type in start again, I'll see that they're highlighted right now. In the bottom area, move some things around, I have this search options button in the bottom right-hand corner. Clicking that, I can then change my behavior from search to filter, and now now it acts as a filter versus search. Also in the search options box is my ability to set the first scrollable column. So if I don't want the column to, this is like freeze frames in Excel. I now have the ability to slide back and forth with that one column frozen. So a little bit of what you see from the output of LNK File Explorer, as well as a little bit on Timeline Explorer. All right. So Prefetch. Prefetch Parser Prefetches are one of the major artifacts of proof of execution, program execution. So that's what is in the artifact. It will give us things like the number of times it was run, the timestamps for the last 8 times it was run, and in particular, it also gives us folders, directories, and files that were accessed during program execution. Basic usage is very similar to what we just did with LNK File Parser or LNK File Explorer. So no need to go through those again, but one thing I do want to point out is that in our basic usage, Prefetch Parser is one of the programs that supports volume shadow copies. So know that going into it. On the left-hand side here, we talk about the fact that we may have red and yellow text. So when the output is sent to the screen, we may see the red and yellow text. Red basically meaning that one of two things has happened. Either it has found the text TMP or TEMP in the path for the directory or the file, or it has gotten a hit on a keyword that you have supplied on the command line. And yellow just points out executables that were referenced when this program was executed. I've reviewed briefly the data that was returned. Advanced usage, I just talked about the ability to use keywords, and I'll show you that in just a second. Prefetch parser against a single file, prefetch parser against a directory, prefetch parser against a directory with a keyword here being download, and using cape to process, using cape to call prefetch parser to process data. So I do a little bit of a demo here. Trying to be conscious of time also because there's some nice commands coming up. So the very simple way, I'm running it against a single prefetch file. See how quick that was, and then see that we have the executable in yellow, and we did not have, let's see, I don't think we did. We did not have any folders or files that met the criteria to color them red. So one of the interesting things that I talked about is that, I'll come back. So we now know from running this command that this particular sdelete program had been run 11 times. The last run timestamp, we also know that it had been run on these other times. We'll keep track of up to 8. Following that, we know what directories were referenced and what specific files were referenced. So we scroll down to the bottom looking at the files, we now can tell that sdelete was used to wipe some specific files. The same information is available if we run it against a directory in spreadsheet form. Okay, so once again, how fast these commands are running. So that was basically a second and a half to process that entire folder of prefetch files. That was put into a file named Prefetch and Prefetch timeline. These particular file names came from the fact that when I invoked the prefetch parser command, I explicitly gave it the name that I wanted the file to be used on, the name I wanted to have used on the output file, prefetch. One thing to point out on prefetch output, when it's sent to a CSV, we get two files. We get the prefetch file, and then we get a timeline version of that file. Also in Timeline Explorer, I can have multiple tabs open, so I'm going to go grab 3 files right now. First file is just the normal prefetch file. So this is what was generated from the directory of prefetch files that I processed. Same information you saw from running it against a single file, just in table format. The second file that gets generated is the prefetch timeline. So what we have done is all of these past run times that we have across in separate columns have now been turned into rows so that we can see every single occurrence or every single run of a program in this view. All right. All right, so that was Prefetch Parser. So these have all been pretty simple examples. I'm going to move on to, let's see, the MFT Explorer. I'm just looking at time, probably running a little bit short, but I want to get to the Registry Explorer at the end. So for MFT-based file systems, for NTFS-based file system, we have the MFT and some associated system files. And what we're talking about when I say that, let's see if we can zoom in here, are the $MFT, the $boot, $J, $log file, and the SDS. Those are the files that we can currently process. The log file output is still under construction, so we don't have that to demo, but we do the other files. So let's just jump into a demo on that real quick. What did I do? So how about, so here I'm going to process the $MFT. So I'm actually processing that file. I am going to place it, I want to generate a CSV format and place it in a file called MFT_CMD_MFT. So I'm processing that single file that contains my MFT. This takes just a couple of seconds to run, but what's amazing is it's going to be under 10 seconds. Okay, so it's like 8 seconds to run that command. On previous tools that parse the MFT, this would have been 8 minutes. It might have been 30 minutes, and considerably longer time than Eric's tool to run. So we've generated that MFT CSV, and the next one I want to generate is the journal. So basically what the journal tells us is the MFT shows me the current state of the NTFS file system. You know, here are all the files, whether they're allocated or not, etc. And the journal tells me at a summary level what happened to a file. You know, was it changed? Was it deleted? That type of information. So having a tool that runs at the command line that runs this fast, that extracts all that journal information is amazing. So that fast to extract, we extracted 367,000 journal entries in a second and a half. If we go look at those real quick. Let's see. So we'll look at just the two from the commands we just ran. And here, just trying to demo the tool, not trying to, give a full explanation on the data or the artifacts that we have just processed. So big files. The journal, well, so the MFT, if you look at the bottom part of the screen down here, you'll see that was 317,000 records in the MFT. In our journal, we have 367,000 lines. Now I'm going to clear the filter that I have right now, and I'm going to take the reasons off. So this is the basic format of the file. What we're primarily interested in, or what we'll be using as a filter, is the reasons. What happened to this particular file? So what I can do is I can say, if I like, for a particular file, WACC as an example. So I'm filtering on that file name. There's a couple of different versions of that file or similar names, and I can see exactly what happened to it. Eric has taken these update reasons and made them very granular, and I can see the timestamp associated with that. Another way of looking at this might be to say, use my group by function, say I'm going to group by update reasons, and now we can see all the different reasons that have been, that we have transactions for, a lot of different ones. And maybe I want to actually filter on update reason and say, let me see the things that were deleted. So I'm just going to choose these two reasons. And now I see all the files that were that had that transaction type of, in this particular case, file delete close. So use the group by function to help make this journal more manageable. This is this data inside this journal has been something that historically not a lot of investigators have utilized because it was difficult to navigate. And now, as you just saw, we can process it in a matter of seconds and use a tool like Registry, like Timeline Explorer, to easily look at that data. All right. So running short on time here. I'm going to take the time in lieu of answering some questions, and I'll be certainly, take any questions that you may have via email or Twitter. I do want to spend the rest of this time and look at one more command. We're skipping event logs, although that is a very nice feature too, to look at the command line version of Registry Explorer. Now, Registry Explorer allows us to do some things like search. Okay, we can search for specific key names. We can search for value names. We can search for actual data within the registry hive that we have given it. We can search a single registry hive, or we can search a directory of registry hives, just like we have been doing on all the other commands. So skipping ahead, one of the things that I want to point out here is that I think you're going to be better off if you get all of your registry files and put them in one location, in a single folder. Cape will help you do that if you would wish to use Cape, or you can do it manually. The other thing is to use the RLA command to go ahead and apply all of your transaction logs to the registry hives that you put in one location. And lastly, I think it's easier if you would build a hard link to your batch file folder. We're going to get to that in just a second. So that your command lines don't become extremely long every time you have to reference a very long path. So when we say search, these are the options that we can use in search. Basically, we are searching a key, we're searching a value name, we're searching the value data. There's regex support. It has the ability to automatically convert hex and Unicode data into ASCII to match the search term. That's better illustrated, I guess, through a demo than to talk about it. So let's do that. So here what I'm doing is I'm searching the registry data for a single file, the ntuser.dat registry hive, and what I'm looking for is Dropbox. And we now see that we have all of this data highlighted in hex. But if we scroll back up, we also see that we have data that appears to be ASCII, and we know how to read and understand that. So what's going on here is the fact that Registry Explorer has taken these values and converted them back into ASCII. So when it compares the ASCII search term, it knows whether it got a hit. So if I look at this real quick, if I copy this value out, oops. And I'm just going to bounce over to CyberChef because this is a very easy way to convert it. And I'm going to drop that value in. And I'm going to say I want to convert from hex. I'm sorry. From hex. And now we see here that, yes, indeed, that is Unicode Dropbox. If we clear this, grab the other value real quick, the shorter one. And we see that, yes, it does convert to Dropbox, also just standard ASCII. So this screen is just showing you different variations of what you can search for. Now, the real power of Registry Explorer command line version is the ability to execute batch files. So I can create a batch file that searches many different registry hives for many different conditions. Dissecting this particular command, I'm telling it to run a batch file named basic-system-information.reb. That's the extension for the batch files. I'm telling it I want to run it on a directory named demo reg. The tac nl means don't worry about converting or processing the dirty hives, just leave them as they are. And then I want you to put the output information into a folder named basic system information. Jumping to a demo of that. Okay, so in this command example, I am running a batch file called user activity. I'm going to run it against a single ntuser.dat file, and I'm going to put the output into this output folder. So all of that ran in under 2 seconds. If we go look at the information that was created, so from that one run of that command, we created all of these CSV files. And all of this has to do with user activity. So that one command allowed me to do things like typed URLs, run MRU, last visited PID MRU, all of those types of user activities that we would normally have to go pull out of individual, do registry searches for. Running that one command gave me all of this CSV information. So a huge time saver. And then lastly, So Jessica, how are we doing on time there?
We'll just wrap up on this topic and then I'll close out the webcast.
Awesome. I'm going to run one more quick command, and if you need to cut me off, you just go right ahead. Okay, I guess it's probably good to just try and wrap up there, Jessica. And the last thing I want to put back up on the screen is my contact information. Just too much information to make it through and talk. Yeah, a lot of information to cover in a short period of time. So my contact information is here on the screen. I'm sorry we didn't get a chance to have any questions and answers at the end. I saw that there were definitely questions in the chat window. Feel free to send those directly to me, and I promise you I will get back to you.
Thank you, Mark, for your great presentation, which helps brings this content to the SANS community. To our audience, we greatly appreciate you listening in.